Alright, AP Calc. In this video, I'm going to go over how to take limits algebraically, focusing on the two types that we went over earlier in class today, by factoring and multiplying by the conjugate. So, first off, we should always try direct substitution, and if we get the form 0 over 0, of course that's not a real number, that's called an indeterminate form. And that means that we need to do some more work with it. And for right now, that work is going to be either to factor or to multiply by the conjugate. So if it looks like these guys, these first four, these are going to be by factoring. Number one, so we're taking the limit as x goes to 3. If we plug that in, we would have 9 minus 9 on top and 3 minus 3 on the bottom, of course giving us 0 over 0. That doesn't mean that the limit is undefined, it just means it's indeterminate. And we need to determinate it. So we're going to start by factoring. One thing we need to do is when we're showing our work is continue writing this limit until we get to the very end and we're able to do direct substitution. So x squared minus 9, of course that can be factored into x plus 3 and x minus 3. And then we go to the bottom and we have x minus 3 there. And at this point, after we factor, the whole reason is so that something nice happens. We can cancel those out. We get the limit as x goes to 3 of x plus 3. Again, we write the limit to this point. I'm just simplifying. And now we can actually plug it in. So we get 3 plus 3, which gives us 6. Number 2, the limit as x goes to 2. So again, if you check, you would have 4 minus 2, that's 0 on top, 0 on the bottom. And so that's a clue that it's indeterminate, and we can see we can factor it. So we're going to start by going limit as x goes to 2. We factor the top into x minus 2, x plus 1. On the bottom, we have the x minus 2. The x minus 2's would cancel, leaving us with the limit as x goes to 2 of x plus 1. Put parentheses around that. And now we can do direct substitution. 2 plus 1, plug 2 in there for x, equals 3. 3 is our final answer. Should box that. Number 3, the limit as x goes to negative 3. And again, we'd have the form 0 over 0. It's always a good idea to check though, because just because it's rational doesn't mean you always have to or always can factor it. So we rewrite. Top, nothing to do there. Bottom factors into x plus 3, x plus 1. We cancel out the x plus 3's. Now when you cancel out the top, it doesn't mean that everything just disappears. Really, we still have a factor of 1 up there, so we should keep that in mind. And so when we simplify this, it looks like we have 1 over x plus 1. Now we can plug in negative 3. And we get negative 1/2. Number 4, the limit as x goes to negative 1. Okay, again, we get 0 over 0, so we can factor, rewrite the limit part here, and top, nothing to do there. Bottom can factor into x minus 3 and x plus 1. The x plus 1's to cancel. Again, we'd have 1 left on top. So we're taking the limit as x goes to negative 1 of 1 over x minus 3, which gives us 1 over negative 1 minus 3, which is negative 1/4 for our final answer. So those are the examples that we did on factoring. Now, number 5 looks a little bit different. So these have square roots in them. They have radicals in them. So again, when we try to plug 9 in here, we want to run into problems. We have 0 on top. Square root of 9 is 3. 3 minus 3 is 0 on the bottom. And so the trick with this is to look at the part that has the radical. And we want to take the conjugate. So the conjugate of a plus b is a minus b, and vice versa. The conjugate of a minus b is a plus b. And we multiply by the conjugate to use this. The fact that when we multiply by the conjugate, we're going to get a difference of squares. So that's going to help us get rid of that nasty square root. So the conjugate here, you just change the middle sign. So if this is minus, then we want a plus here. And if it's plus here, well, we want a minus. So the conjugate would be square root of x plus 3. If you multiply the denominator by that, then we also have to multiply the numerator by the same thing. Now let me write it down here so I have room. The whole reason for that is because now we're going to multiply the denominator out. We're going to FOIL it. Square root times a square root. Well, it's the same square root, so it's going to unsquare root itself and give us back x. Square root of x times square root of x is just what's underneath. It's just x. The outside, we would have 3 square roots of x. The inside, we're going to have negative 3 square roots of x. They're going to cancel out. That's what makes this trick work, is when we FOIL, the outside and the inside would end up canceling each other out, and we're just left with the first terms squared and the last terms squared. So outside and inside cancel out, and then negative 3 times 3 would be negative 9. Now the top, it looks like you might want to try to multiply it out, but actually we just want to leave it in factored form. So the top we want to leave in factored form. Do you see why? Because now we can cancel out these x minus 9s. So that part goes away. Now it doesn't, just has a 1 in the denominator. Now we can simplify this even more. We just have the limit as x goes to 9 of the square root of x plus 3. At that point, we can do direct substitution, plug in 9, and we get 6. 3 plus 3 is 6. Okay, 6 looks very similar. We have the square root of x minus 4 over the x minus 16. If we plug in 16, again, we would have problems. But let's see, we want to multiply by the conjugate of the thing, the radical thing here. So the conjugate, well, that's a minus. Then we want to have a plus sign here. And we do the same thing on the bottom. So we are going to end up foiling on the top, but leaving it on the bottom. So that gives us the limit as x goes to 16. On the top, again, foiling. Square root of x times square root of x is just an x. Outside and inside cancel out, so you don't have to write those. Negative 4 times 4 would be negative 16. Lucky us, we have an x minus 16 on the bottom. So that will cancel out. Again, I'll write a little 1 there to remind me that there's still something on top. It's just 1. And so really this simplifies down to the limit as x goes to 16 of 1 over the square root of x plus 4. Now we can plug in square root of 16 plus 4. 4 plus 4, that gives us 1/8. All right, 2 more. 7 and 8 look a little bit more challenging. Why? Because now it's a little bigger here. But we still have the square root of something minus something on the outside. We want to multiply by the conjugate. The whole idea of multiplying by the conjugate is to get rid of the square root. So we definitely need to have another square root here. And in order for us to unsquare this square root of x minus 6, we need to make sure it's the same thing. So we don't flip this sign, we flip the outer sign. So if it's minus here, the conjugate would make it plus. Minus 1, we want plus 1. And whatever we do to one part of the fraction, we need to do to the other part. So we multiply the top and the bottom by the conjugate. This one's going to require a little bit more work, so let's write it out. A square root of x minus 6 times a square root of x minus 6 just gives us the stuff underneath, which is x minus 6. Outside and inside, again, would cancel out, so we don't have to worry about that. And then multiply. Negative 1 times 1 would be negative 1. The bottom, leave factored, just going to put these factors in parentheses for now. And now, what does this help us? Well, this x minus 6 minus 1 is really x minus 7. So if you want to think of this as x minus 7, then it will cancel out with this x minus 7. So we'd have 1 left on top. We can take the limit as x goes to 7 of 1 over the square root of x minus 6 plus 1. Now we can plug in. We are plugging in a 7. And after all of that, we get 1/2. Okay. And the last problem in this set here, the limit as x goes to 5 of x minus 5 over the square root of x plus 4 minus 3. We're going to multiply by the conjugate, square root of x plus 4 plus 3. Again, we want the stuff in the square root to remain the same, so we don't change that sign. We change the outside sign. And whatever we do to that bottom, we have to do to the top. We're going to FOIL the top and leave the bottom, FOIL the bottom and leave the top unfactored, or in factor form. So the square root of x plus 4 times the square root of x plus 4 on the bottom would give us just x plus 4. FOIL this out. Outside and inside would cancel. Negative 3 times 3, be careful here, gives us negative 9. So last times last gives us negative 9. On the top, we have x minus 5. Then we have all of this, x square root of x plus 4 plus 3. Now, this x plus 4 minus 9, that's really x minus 5, which will cancel out with that. So we're taking the limit as x goes to 5 of just this thing, x square root of x plus 4 plus 3. And we can plug 5 in there now. 5 plus 4 is 9. Square root of 9 is 3. 3 plus 3 is 6. All right, so hopefully that helps. Bye for now.